As we all know, wheeled robots are very common in our daily lives. Do you know how wheeled robots measure speed? How can we accurately control the motion state of wheeled robots? The traditional method of measuring speed is to measure the distance traveled by car within a fixed time, divide it by time to calculate speed. However, this method cannot obtain the current implementation speed of the motor encoder. In order to solve this problem, the motor encoder came into being. It can not only calculate the motor speed in real time, but also obtain the forward and reverse information. With this information, we can monitor and adjust the robot's behavior in real time, such as realizing precise motion control and path planning, enabling it to avoid obstacles in complex environments, realize attitude adjustment and balance control, and can adjust the attitude and center of gravity position of the car in real time to keep it balanced. There are many application scenarios for encoder motors, such as ROS robots, balance cars, navigation and positioning cars, etc. An encoder is a sensor used to measure mechanical rotation or displacement. According to the encoder mode, it can be divided into absolute and incremental encoders. Incremental encoder is to change the only information of motor movement into continuous pulse signal. The number of pulses indicates the displacement, can only read the amount of motor change. The position, speed and direction of the motor can be calculated by amount of motor change, can be used for real-time monitoring and motor speed adjustment. Absolute encoder motors typically have multiple tracks or encoding bits. Each bit represents a different binary code. These binary codes are combined into a unique position value. The absolute position of the motor can be expressed directly. Absolute encoder motors provide accurate absolute position information without a reset process. Each position value corresponds to a specific angle, enabling accurate positioning and control of the motor. For example, for surgical robots, absolute encoder motors can provide accurate joint position information to help doctors perform precise surgical operations. According to the detection principle, it can be divided into photoelectric encoder and Hall encoder. Today we mainly introduce Hall encoders to you. The Hall encoder is mainly composed of a Hall device and a magnetic ring. For example, the encoder of this motor is composed of a magnetic ring and two Hall devices. Its magnetic ring has 11 wires, which is equivalent to 11 graded magnets evenly distributed on the magnetic ring. The data obtained by the two Hall devices can be called phase and phase B. We assume that when the motor rotates, the Hall devices is at a high level when it corresponds to the N, and then it is at a low level when it corresponds to the S, when the motor rotates. Due to the position difference of the two Hall devices, the collected pulse signals are also different. This is the pulse signal received by the two Hall devices when the motor rotates. By observing the two sets of signals, we can see that the phase difference is 100 degrees. We can judge the rotation direction of the motor according to their sequence, according to the number of signal pulses per unit time and the circumference of the tire. The current running distance of the tire can be calculated. If we only detect the number of pulses of the AB phase per unit time, we can also measure the current motor speed. 130 reduction ratio as an example. When the motor makes 1 revolution, the single phase output 11 pulses. So when the output shaft of the motor rotates 1 revolution, the maximum output is 30*11* for equals 1320 counts. In summary, using motors with Hall encoders is a common choice for velocity measurement in the field of wheeled robotics. By observing the phase difference of the two sets of signals output by the Hall encoder, we can judge the rotation direction of the motor. According to the number of signal pulses per unit time and the circumference of the tire, the traveling distance of the car can be calculated, and monitor motor speed in real time. This information is critical for precise motion control, path planning, and attitude adjustment. Hall encoders realize precise speed measurement and position feedback in the field of wheeled robots, providing accurate motion control and positioning capabilities for wheeled robots, enabling them to avoid obstacles and maintain balance in complex environments.